Hey guys, how you doing? How are you doing? Today we're talking about equilibrium. Now, equilibrium is a large area of chemistry, but today we're not going to talk all about it. I'm just going to give you a quick introduction, what it's about, what it means, and I'm going to give you a just one equation that we're going to use to do some simple calculations. But by the end of this video, you should know exactly what equilibrium is, what is an equilibrium constant, and how to calculate that. All right, let's do this. Okay, so when we're talking about equilibrium, we're really referring to chemical equations and chemical reactions, and you should know by now what chemical reactions are. So if you have a chemical reaction, let's say, let me see if I can write here, A plus B gives you C plus D. This is a simple equation that's telling you that you take A plus B, which are the reactants, you they give you C plus D, which are the products. But in nature, we found out that a lot of reactions don't happen this way. A lot of reactions are reversible. What does that mean? It means that in addition to your reactants making products, the products also make reactants. So instead of having this arrow right here, you have another arrow back like that. Right? That's it. That's it. Bad arrow. Let me write it down again. There you go. So you have a reversible reaction, right? And what that means is that really, as you're making the product is making more reactants, and it's going to get to a point where they are the same level. And what do we call that? Equilibrium, right? That's where equilibrium comes from. You're making a forward reaction, you're also making a reverse reaction to the point where you reach equilibrium, right? And most of the reactions in the lab and in nature achieve equilibrium. And there are so many different types of reactions and so many different types of equilibrium. And let me talk about a few. So first you have a physical equilibrium versus chemical equilibrium. Now, a physical equilibrium is easy if you know what a physical change is. And a physical change is a change that only changes the matter but not the chemical, not the chemistry, right? So for example, if you're melting ice into water, it's still H2O. You haven't changed the molecules. You're just changing the physical characteristics of it. That's a physical change. So the equilibrium, when it comes to the physical equilibrium is the equilibrium that involves the change in physical properties to the point where you have an equilibrium. So at the bottom here I say that when all the physical elements of something are equal or the same, right? So it's equilibrium when it comes to physical changes. Now, a chemical equilibrium is the opposite. It's when it comes to chemical changes. So when we involve a chemical change, a chemical reaction, you have a chemical equilibrium, right? So when a chemical reaction does not go to completion, a chemical equilibrium is established between the forward and the reverse reaction, right? And then in the end, you're going to have chemical elements of something will be around equal. So the products and the reactants will be equal, right? And there's another type of way we characterize reactions. We say dynamic versus static equilibrium. Now, dynamic versus static equilibrium can be confusing, but really, first of all, dynamic equilibriums are reversible in nature versus the static equilibriums are irreversible in nature. And the equilibrium here implies that the reactants and the products are still participating in the reactions, and the static equilibrium means that we're no longer participating in the reaction. And when you have a dynamic equilibrium, the forward and backward reactions rates are equal. When we say rates here in chemistry, what we mean is speed. Speed of the reaction is equal. And in static equilibrium, the forward and backward reaction rates are zero because we no longer we're no longer participating in a reaction. It's a static equilibrium. And the dynamic equilibrium occurs in closed systems, and static equilibrium occurs in both open and closed system. And I have a video talking about what a closed and open system is. Now, I talked about rate. So this is what happens in equilibrium. The rate of the forward reaction, the reaction that's producing the products, is going to be going down over time. And the rate of the reverse reaction is going to go up over time. And they're going to get to a point where they are equal. The rates, meaning the speed, are equal. And when the speeds are equal, you have achieved the equilibrium, right? So the reaction doesn't completely stop to achieve equilibrium. What it means is that the speed of the forward reaction and the speed of the reverse reaction are equal. So you've achieved equilibrium between the reactants and the products. So that's what equilibrium is, and that should be enough for you to know what equilibrium is. Now let's go to what we call the equilibrium constant. So this is a way to measure or quantify equilibrium. And it's pretty easy. Let me show you. If you have your equation, right? The equation that I showed you guys, like A plus B equals C plus D, right? A and B are the reactants, C and D are the products, right? So if you have that, then the equilibrium constant. So first of all, when you're at equilibrium, the rate of product formation is equal to the rate of reactant formation. That's what we just saw here. So because of that, you can calculate that rate, the equilibrium constant, right? And using this reaction, the equilibrium expression, KEQ, you'll see this a lot when you continue to study chemistry. You'll see K is the equilibrium, the constant, the equilibrium constant. And KEQ, the equilibrium constant, is going to be equal to the product of the concentrations of the product. So when you see this bracket, it means concentration. So it's the concentrations of the products over the concentrations of the reactants. And then, very important, you're going to use the coefficients as opponents here, as exponents here, all right? Let me show you if it's not clear. So you have, for example, H2 plus O2 is equal to H2O. But it's a reverse reaction that goes to equilibrium, and let's make sure that it's balanced. So if I asked you to write down the equilibrium expression, is KEQ is equal to the concentration of the product. So the concentration of H2O. Again, the brackets means concentration, and the coefficients will be exponents. So this will be square over the concentration of the reactants. So H2 here squared, because you have 2 here, O2 times O2. So the products on the top, the reactants at the bottom, you use concentrations, and you use coefficients as exponents. All right, let's look at another one. What if I say, okay, let's say CH4 plus O2 is equal to reversible reaction H2O plus CO2. 2. All right, let's see if we can balance this reaction quick. Let's put 2 here. That's 4 hydrogens. And then you have 4 oxygens. All right, and 1 carbon. Good. All right. If this is a reversible reaction and it goes to equilibrium, what's the equilibrium constant? KEQ is equal to the concentration of the product. So concentration of H2O squared times concentration of CO2, not squared because there is nothing here, over the concentration of CH4 with nothing on it, times the concentration of O2 squared, because you have 2 as a component here, as a coefficient here. By the way, this reaction in real life will never be reversible, but this is just a random example that I'm giving you. But in real life, this reaction is forward. It's not reversible at all because it's a combustion reaction, right? If you made something ashes, you can't go back to the gas and oxygen. But this is how you would do it if it was reversible. Let's look at another example, just to make sure that everybody understands. All right, so let's say you have, I don't know, NH3 gives you H2 plus N2. All right, balance the reaction, and then if it's reversible and goes to equilibrium, what's the equilibrium constant expression? It's KEQ is equal to the concentration of H2 to the third, because you have 3 here, times concentration of N2 over the concentration of NH3 what? Squared, right? That's how you just find the concentration, the equilibrium constant expression. Now, here is the thing. Now that you know how to do this, if I give you these concentrations, can you find the KEQ? Yes, you can. You just put in the numbers. You plug in the numbers, you get the concentration. Right? So this is pretty much what you can do. So if you have a balanced chemical reaction, you can find the equilibrium expression, right? Just like we just did. And using the equilibrium expression and known values of the concentrations, you can find the value of K, right? And there's a reason why we call it the equilibrium constant. The same equation, under the same conditions, the K will not change. Even if you change concentrations, if you change other things, if you have the same conditions and the same reaction, the equilibrium constant will not change, right? So you got to remember to do that. So let's look at an example of finding the actual K. So here, write an equilibrium expression for the following equation. All right, first of all, let's do that. We just learned how to do that. The equilibrium expression is very easy. KEQ is equal to concentration of CH4 over concentration of H2 squared, you can't forget that, times concentration of C. All right, that's the equilibrium expression. Good. Now, after that, they're saying, using the equilibrium expression from the question above that we just did, calculate the equilibrium constant. Now, they gave you the values for each. So you just got this, and they gave us the values for each of these concentrations. Can you find the KEQ? Yes, you can. All right, let's move this above here so that we can do it. All right, so we got the values, we got the KEQ expression. Can we find it? Yes, so all you gotta do is say KEQ is equal to the concentration of CH4. They gave it to us is 7.3 times 10 to the negative 1 molar over the concentration of H2. They gave it to us. It's 2.1 times 10 to the negative 1 molar. But do not forget squared, because you have squared for hydrogen, and then times the concentration of carbon, which is 1.1 times 10 to the negative 6 molar. All right. Then you can do this on your calculator and see what you get. Now, before you do that, one thing that I'll tell you is this. You see how you have molar here? Down here you will have molar squared. And then here you have another molar. So that's molar over molar squared times molar, right? So the units for KEQ change depending on what you have in here, right? So for this one, for example, will be molar over molar squared times molar, right? Which is molar over molar cubed, which is 1 over molar squared. So the KEQ units change from equation to equation. They change from equation to equation, and you gotta know how to do that, right? For this introduction class, I want you to just skip the units and just give me the number, but know that the units change depending on what you have, all right? But for this one, I just want you to go ahead and calculate it and tell me what the answer is. But that's pretty much how you do it. All right, let's actually do it on the calculator. All right. All right, I find 1.5 times 10 to the 7th. 1.5 times 10 to the 7th. And again, the units here will be 1 over m squared, but if you don't give me the units, I'll take it because it's just an intro class. It should be fine. All right. So another thing to note is this. If you get KEQ, right? So there are two numbers I want you to remember. If you find KEQ, right, and it says 0.01 100, right? So if your KEQ is really small, so I want you to look at the formula. This is the formula. You have the products over the reactants. So if the KEQ is really small, it means that the products are really, really, really small compared to the reactants, meaning that if your KEQ is below 0.01, what is happening is that you have in your reaction, you have mostly the reactants. It's really hard to write here. Okay. All right. And then if you have over 100, that means that you have a bigger number, meaning that the number on top is big, meaning that you have mostly your products. And then if you have something in between, it means that you have a mixture of reactants and products. There you go. So every number that you get, I can ask you, hey, with this KEQ, which one is predominant? The product or the reactants? All right, and you'll be able to answer that no problem. All right, so Now that you know how to calculate KEQ like this, right, from an equation, what if I give it to you backwards like this? So I can give you the KEQ. I can give you the KEQ. I can give you other concentrations and ask you one of them. But it's just pretty easy, pretty straightforward. So this is the equation that we have. If we have this equation, means that the KEQ is going to be equal to the concentration of the products. The products here is NH3 squared, and then the reactant is N2, and then H2 to the third. All right. And then here's what they are saying. They're giving you the KEQ. They're giving you the concentration of H2. They're giving you the concentration of N2. And they're asking you the concentration of NH3 squared. Well, let's just go ahead and substitute, right? They say KEQ is 20. NH3 concentration is what we don't know. So let's call it X. So X squared over the H2, the N2 concentration here is 0.15 molar, and then the H2 concentration is 0.1, and don't forget the cubed. All right, so all we have to do is just solve for X. All right, so X squared is equal to 20 times 0.15 times 0.1 cube. All right, let's see what we got here. 0.1 cubed times 0.15 times 20. So it's 0.003. All right, so X squared is equal to 0.003. All right, how about X? X is the square root of X squared. So it's square root of 0.003. All right, let's see what we got here. It's equal to 0. So X is equal to 0.055 molar. That's the concentration of NH2, NH3. That's what we were looking for. So you see that these are just straightforward calculations that you probably have done before. And that's pretty much the basics when it comes to equilibrium. And let me know what else you want me to cover or any questions that you have. Have a good one. Bye.